All right, guys, we're going to talk more about bisectors of triangles today. Students will be able to use and find the circumcenter and incenter of a triangle. Okay, so we've already talked about what a circumcenter is. It says if PD, PF, and PE are perpendicular bisectors, then that means the length of PA is equal to the length of PB, which is equal to the length of PC. Okay, so what that means is if it says PD is a perpendicular bisector, so that means that this line is perpendicular to the side AB and these two segments are congruent. If PE is a perpendicular bisector, that means it's perpendicular, and that means these two segments are congruent. And if PF is a perpendicular bisector, then that means that's a right angle, and all three of these are congruent. Or both of those are congruent also. Okay, so those are perpendicular bisectors. So the blue lines are perpendicular bisectors. Where the perpendicular bisectors meet at right here is the circumcenter. Okay, now what that second part means is from the circumcenter to point B, and then from the circumcenter to point A, and from the circumcenter to point C is all the same distance. So that means this segment here is the same length as this segment, which is also the same length as this segment. So whenever you have the perpendicular bisectors where they meet at the circumcenter, it's equidistant to the three angles. So just like in our problem where we had to find the location that was the same distance from the high school, southwest, and central, we had to find the circumcenter. So same thing here. That would be the circumcenter is the same distance to all three angles. All right, and then the second thing we talked about was the incenter theorem. The incenter theorem is where all the angle, or the incenter is where all the angle bisectors meet. Okay, so it says AP, BP, and CP are angle bisectors. So what that means is this line segment here, AP, it cuts angle A into two congruent angles. The segment PB cuts this segment into two congruent angles. And then this segment here, PC, cuts this angle into two congruent angles. Sorry, I'm going to say angle B into two congruent angles. So it cut angle C into two congruent angles. So all the red segments are angle bisectors. Okay. Now, where they meet at is called the incenter. Okay, so this is the incenter, this point here. What this means is from the incenter to each of the sides will be the same length. So PD would be congruent to PE, which would also be congruent to PF. So all three of these blue lines would be the same length. So they go backwards from each other. The angle bisectors, the incenter is the same distance to the sides. And then back with the other previous one, the perpendicular bisectors, they came from the sides. They're the same distance to the angles. Okay. All right. So what we're going to do is you are going to determine if it would be best to use the incenter or the circumcenter to recommend a location. Okay. So let's look at the first one, teacher model. So this one I'll do completely on my own. It says 3 snack carts sell frozen yogurt from points A, B, and C. So here's A, B, and C. Outside a city. So the city is located on the inside. Each of the 3 carts is the same distance from the frozen yogurt distributor. Okay. Would you use the circumcenter or incenter to find the location of the distributor? And there's a typo right there, and it should also be a question mark. And then explain. All right, so we need to figure out if we would use the incenter or the circumcenter. So the circumcenter is where all of the perpendicular bisectors meet. The incenter is where all the angle bisectors meet. Okay, and then I remembered just previously, the perpendicular bisector, that's where the circumcenter is. The circumcenter is equidistant to the angles. the in-center is equidistant to the sides. So you have to figure out, do these locations, the frozen yogurt locations, do they represent the sides of the triangle or do they represent the angles? And since it's just a single location, those would each represent the angles. Okay, so I'm trying to find a point that's equidistant to the angles, so that would be the circumcenter. So I would tell them that they would use the circumcenter, and that would be because the circumcenter is equidistant to the angles. Or also the snack carts, because the snack carts or the angles represent the snack carts. Okay, all right, let's try another one. A city wants to place a lamppost on the boulevard shown so that the lamppost is the same distance from all 3 streets. Should the location of the lamppost be at the circumcenter or the in-center of the triangular boulevard? Okay, so look at this like a triangle. Okay, so here's one side of the triangle. Here's another side. And there's the third side. Okay, and it says it wants the lamppost the same distance from all 3 streets. So you need to think about the street. Does the street represent the side of a triangle or does it represent an angle? Okay, all right, so the streets represent the sides. So you want a location that's equidistant to the sides of the triangle. Okay, so you want all 3 of these to be the same. And based on that, we would use the in-center. Okay, and why exactly would we use the in-center? Okay, yeah, so it's because the in-center is equidistant to the sides of the triangle, and the streets represent the side. Okay, let's try another one. Okay, actually, you're going to try this one on your own. It says a carnival operator wants to locate a food stand so that it is the same distance from the carousel, the Ferris wheel, and the bumper cars. You need to find the location of the food stand, S. Okay, so you need to explain, would we use the circumcenter or the in-center, and why? All right, let's say you're given some measurements and you need to find a missing measurement. This is chunk 2. It says in the figure shown, the length of ND is 5 and NC is 8. Find the length of NF. So the first thing I'm going to do is mark these lengths. So I'm going to mark ND 5 units. So from N to D is 5 units. And then from N to C is 8 units. So that's this red segment right here. Okay. And they want me to find NF, which is here. Okay. All right. Now to solve this, what you want to do, you want to figure out if this location is the circumcenter or in-center. Okay. If it's the circumcenter, then it's going to be where perpendicular bisectors meet. And whenever you are looking for perpendicular bisectors, you want to see that the lines are in the midpoints of the side. So like if it was a perpendicular bisector, it would be a right angle and these 2 segments would be marked congruent, or it would tell you they were perpendicular bisectors. But see how BE and EC are not marked congruent? So this would not be a perpendicular bisector, okay? Now, to look for an angle bisector, you want to see if the two angles are marked congruent. So if you look here at angle B, see how these two are marked congruent? Angle A, these two are marked congruent. Angle C is marked congruent. Okay, so these red lines are angle bisectors. And then, so which means that point N is the incenter. Okay. And then from earlier, we know the incenter is the same distance to all the sides. So that means that this side here in E would be congruent to the side in F, and that would be congruent to the side in D. So if ND is 5, then NF would also be 5. So our answer would be 5. Okay, so let's try this one. It says in the diagram, the perpendicular bisectors, so it tells us, of triangle ABC meet at point G and are shown dashed. Find the indicated measure. Okay, so there's a couple of these on your paper that you have to find, and we're going to find each of those. Okay, so the first thing you want to do, or the first thing I would do, is mark anything that I know is going to be congruent. Since it says they're the perpendicular bisectors, then and they're the dashed lines, I know that these two segments would be perpendicular, and I know these two segments are congruent to each other. Same over here. These are right angles, and this segment's congruent. Right here, GF, that would be a right angle, and then this segment here would be congruent to this segment here. Now, my question for you. Would G be considered the circumcenter or the incenter? Okay. Since G is where all the perpendicular bisectors meet, it's the circumcenter. Now, my next question. Is the circumcenter, is it equidistant to the angles of the triangle or to the sides? Okay. All right, so it's equidistant to all the angles. Okay. So what that means is I can mark GB congruent to GA, and I can also mark it congruent to GC. Okay. Now that I have everything marked congruent, now I can go through and start finding the lengths of the missing measurements. So the first measurement they wanted me to find was CF, the length of CF. Okay, well, you can see here, and also let me go back and put 4 marks on these, since these I already used 3, so that needs to be 4 marks instead of 3. All right, so if I look at CF, it's marked congruent to AF. And if AF is 24, that means CF will also be 24. Okay. The next one it wanted us to find was BC. Well, BE is 15, so that means EC will also be 15. So BC would be what? Correct. So it would be 30. BC would be 30. You would have to do 15 plus 15. All right, the next one wanted us to find BG. Okay, what do you think the length of BG will be? Okay. All right, so BG is marked congruent to GC, which is also to GA. And if GC is 25, this one, AG would be 25, and BG would also be 25. All right, let's try another one. In the figure shown, QM is 3 and find QP. Okay, so QM is 3, so that's this one here. So in order to do this, we need to figure out if this is the incenter or circumcenter. So which one do you think it is? All right, so if I look here, these lines are perpendicular, but KN is not marked congruent to NL, so they can't be the perpendicular bisectors. But if I look here, these are both angle bisectors because these are marked congruent. So this is where the angle, these red segments are the angle bisectors. So that means Q is the incenter. Okay, now is the incenter, is it equidistant to the sides or the angles? Right, yeah, so the incenter is equidistant to the sides. So that means this line, QP, would be congruent to QN, which is also congruent to QM. So if QM's 3, QP would also have to be 3. All right, you're going to try this one here on your own. It says NE equals 6 and NB equals 3. Find the length of ND. Okay. All right, so try this one here on your own. And then once you type in your answer, it should give you the correct answer. Thank you. Let me know if you have any questions. You can email me, and y'all have a good day.